This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 7, Planetary Gear Trains. Every gear pair so far had fixed shaft centers, so one formula covered every case. Now let one gear ride on a rotating arm and orbit another, and the speed math changes completely. The ratio depends on which member you hold still. A planetary set has 4 members, a sun at the center, a ring outside, planets between them, and the carrier arm that holds the planets. The Handbook's approach is unusual. It does not derive a ratio. It prints a page of labeled figures and asks you to match your train to the one with the same fixed member, driver, and follower. Then read its ratio straight off. Match it right, and the arithmetic is trivial. Match it wrong, and every number is wrong. Concept: match the figure. With fixed shaft centers, one formula covers every gear pair. Let a gear orbit on a carrier arm, and that breaks. The ratio now depends on which member is held still. The Handbook answers this in an unusual way. Instead of a general equation, it prints a page of labeled figures and asks you to name 3 roles: the fixed member, the driver, and the follower. Then find a single figure with that exact geometry and read its ratio straight off. Every common case is already solved. The entire skill is matching the picture. Anatomy: the 4 members. A planetary set stacks about one axis. At the center is the sun. Around it, planet gears mesh the sun on the inside and the ring on the outside, so they both spin and orbit. The ring is the internal gear enclosing the set, and the carrier arm holds the planet axles and orbits with them. Any of the sun, ring, or arm can be the driver, the follower, or the member held fixed. The planets usually just carry the load across. One thing to fix in your mind: the carrier arm is a real member. It can drive or follow, but it has no teeth, so it never shows up as a size in a ratio. The Handbook's symbols. Every figure on the page shares one shorthand. D is the driver's rotation per turn of the follower. F is the follower's rotation per turn of the driver, and the two are reciprocals. F equals 1 over D. A is the size of the driving gear, B the driven gear or follower, and C the fixed gear. Lowercase x and y size a compound planet. 2 rules ride with the letters. Use either tooth count or pitch diameter, but never mix them in one formula. And A, B, and C are roles, not parts. A gear that drives in one setup becomes the fixed C in the next, so relabel every time the setup changes. Reading the figure page. A few figures show the pattern. In the first 4, the follower is the planet spinning about its own axis. With an external gear fixed, the ratio is 1 plus C over B. The fixed gear adds. Make the fixed member an internal ring, and the sign flips to minus. A bevel arrangement gives simply C over B. And a compound stepped planet splits the term into its 2 sizes, X and Y. So the geometry writes the formula. An external fixed gear adds, an internal fixed ring subtracts. A compound planet brings in X and Y. 12 figures cover the sun, ring, and arm-driven sets, so you never derive a ratio, you match a picture. Setup: the worked train. One set of gears driven 2 different ways. First, hold the ring still, drive the sun, and take the carrier arm as the output. The sun has 30 teeth, the ring 90, and the 3 planets 30 each. Tooth counts stand in for gear sizes. At a common module, teeth track pitch diameter, the point from lesson 4. So either works, as long as you stay in one. The planet count falls out of the mesh geometry, and the planets carry the load or drop out of the speed ratio. The arm has no teeth, so it never enters as a size. Solve. Ring fixed. Match the geometry. Fixed ring, driving sun, follower arm, to the page. It is figure 10, which prints D equals 1 plus C over A. With C the fixed ring and A the driving sun, D comes out to 4. The sun turns 4 times to walk the carrier once around, a 4-to-1 reduction in the same direction. Invert for follower per driver. F is a quarter. And a train value check agrees, confirming the match. Solve. Change the fixed member. Same 3 gears, But now clamp the sun, drive the carrier arm, and take the ring as output. New roles, new figure. Fixed sun, driving arm, follower ring is figure 9, which prints F equals 1 plus C over B. C is always the fixed gear, here the sun, and B the follower ring, giving F of about 1.33. Same hardware, but holding the sun instead of the ring gives a completely different ratio. The ratio is not a property of the gears, it is a property of which member you hold. Traps. 5 ways this bites. 1. Using a formula whose figure doesn't match. The number 1 error. The figures differ in which member is fixed, so confirm the fixed member, the driver, and the follower before reading any formula. 2. F versus D inversion. D is driver turns per follower turn. F is the reciprocal. Read which one the figure prints and which the question wants. 3. C is always the fixed gear. When you change what is held, C moves to it. The sun was A in the first setup and C in the second. 4. Teeth or pitch diameters, never mixed. Both work, but stay in one. 5. The arm is a member but has no teeth, so it never appears as a size in a ratio. Quick recall. The symbol law. F equals 1 over D, with C the fixed gear, A the driver, B the follower. A fixed external gear gives 1 plus C over B. A fixed internal ring flips the sign to minus. Hold the sun and the arm drives the ring at 1 plus C over B. Hold the ring and the sun drives the arm at D equals 1 plus C over A. A compound planet brings in the X and Y sizes. Golden rule. The ratio belongs to the setup, not the gears. Match your fixed member, driver, and follower to a figure. Read its D or F, and invert if the question wants the other. Next up, Lesson 8, Belts and Chain Drives. Gears set an exact ratio through meshing teeth. Belts and chains instead span a distance, trading a little slip and some tension bookkeeping for cheap, quiet, long center drives. Lesson 8 builds the belt friction relation, the tight and slack side tensions, and the power a flexible drive can carry. Everything is at PEPrepengine.com. A cheat sheet, work solution, and quiz attached here.
The full study guide, with every equation and common exam trap, is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.